DK, welcome. Good to see you again after a couple of years since our last meeting in Mumbai. So, how are you doing?
Thank you, Manu. Nice meeting, and really appreciate your call and this chance to interact and catch up. Yeah, as you said, it's been a couple of years, but we do see each other online from time to time, but it's never the same.
Yep, that's true. How are you doing in Hong Kong? I mean, how's Hong Kong?
Yeah, I mean, Hong Kong has been a fantastic break for me in many ways, very positive from the hurly-burly of India. But of late, I've started really benefiting from the time that I have got here. Even though I miss family, and the biggest drawback is Bhavita and Anish back home, although they would have been here if the pandemic had not hit. But other than that, I think I can't complain. I really feel very lucky and privileged in many ways. Yeah, Hong Kong has been really good.
How long have you been in Hong Kong now? I mean,
yeah, it's going to be 3 years, Manoj. This end September is going to complete 3 years. I came only for a year, but now looks like
that always happens. Yeah. So what are you currently doing your work on? What's the area of research these days?
Yeah, I mean, as you know, my position is still the same. I'm a visiting research scholar here at HKUST, Hong Kong University of Science and Technology. And so I was invited by Professor Christopher Leong, who is my host here. And he's a world-renowned authority in my area of research, which is fibre-reinforced composites. And he and I actually did our PhDs with the same person in US. He was senior to me, and Professor Victor Lee, who is a bigger authority in the subject, is also happens to be from Hong Kong. And of course, my host, Christopher Leong, is also from Hong Kong. Now, Chris had done his PhD at MIT, where Victor was originally there. And then he moved to Michigan, where I joined him as his second PhD student in Michigan, early in 90s. And after that, as you know, I came back to India and worked for LCC, where we had worked together.
Yep.
So that's the whole connection. So recently, when I read Chris's research work and wrote to him, because it was of interest to both me and to India in general, you can say, because this research is about fly ash in concrete and in composites, and it takes that work to a different level altogether. So I can tell you a little bit more if you're interested, but so that's what brought me here.
Yeah, I mean, just for general interest, I mean, some of the friends who would likely to be seeing this, and what's the kind of outcome that you would expect to see from the research? I mean, in terms of development, in a nutshell, in layman's terms, I guess.
Sure. So like you may recall, when we were working at SEC, Flyash was, in civil engineering, things take a long time, innovation much longer than in other fields. So Flyash concrete has been around for 30, 40, 50 years even. Yep. And Professor Malhotra, the CanMed project, basically promoted concrete with up to 50 to 60% fly ash, which we used to call high volume fly ash concrete. The research that Chris done recently shows that you can actually replace cement by up to 80% fly ash. So those who may not know, fly ash is the waste that you get out of thermal power plants from burning of coal. So it's the unburnt residue. And so if you can use that in concrete and up to 80%, which we call ultra volume fly ash concrete, ultra high volume fly ash concrete instead of just high volume fly ash concrete, then it has a tremendous implication for the environment, for cost of concrete. In fact, the quality of the concrete also improves in many ways. So that's the area mainly that when I read about this, I thought it's very relevant to India, because particularly Odisha also, because Odisha has a lot of fly ash, a lot of coal. And so that was my interest in trying to come here and understand the work and try to take it back when I return. Yeah.
Okay. Interesting. I think, well, people, anyone who's more interested in the topic, in the technicalities of that, should reach out to you for all the information. Yeah.
Yeah, I hope it was clear enough for,
no, I
for
think
a person not from this background. So,
yeah, I think I get a broad sense of it. I guess, from a layman's perspective, I mean, just there are a couple of questions, and forgive me if these questions sound stupid, but, on the one side, you see the attempt to decrease reliance on thermal power plants, coal-driven thermal plants and all that stuff. So, I mean, I've got two, I think, elementary questions. Yeah. One is, with all this emphasis on environment benefits and stuff, and the general attempt to cut down on coal and or coal-based stuff, does that affect the overall production of fly ash and then the availability? That's one. And two is, if say you said 80% replacement of cement, does this actually present a threat to cement plants? And why would cement plants be willing to kind of want to take this up?
Very good questions, Manoj. We can actually talk much more in detail, but basically you are right. Thermal power plants are on their way out. Thermal power being replaced by renewable energy increasingly by wind and solar, and they should go out because they do cause a lot of pollution. But at the same time, the residue, the waste that is there, the fly ash, much of which is getting used nowadays, but a lot of it earlier, which was not used, was dumped, as you know, in fly ash ponds. And they're still there, in millions of metric tons, and those also can be used. So that's a good thing. But as you rightly pointed out, fly ash availability is now increasingly a problem in many parts of the world, and it will become less and less available as we go forward. We'll use more of the old fly ash in the pond, but even that will run out because, as you know, cement consumption is like 3 billion tons a year worldwide, and that's a lot of cement to be replaced with fly ash, and we don't generate enough fly ash to replace the cement appropriately. But the good thing is the second level of research that I've gotten into after coming here is to, instead of fly ash, which will run out and is not adequately available everywhere, is something called calcined clay. So calcined clay is the latest material that we are working on that can replace cement and take the place of fly ash. And unlike fly ash, calcined clay is available in plenty. In the sense, clay is the most widely available material in the world. Clay goes into making of cement also. But the waste clay, or the clay that is not suitable for cement manufacturing, can be converted into calcined clay, which basically is heating it up to 700, 800 degrees to make it reactive. Then it acts like a fly ash. So the current research is that up to 50% of cement can be replaced by calcined clay and limestone powder. So that's called limestone calcined clay cement. So LCC. Okay. So
the acronym rings a bell, I think. I mean, I might have spotted it somewhere, but yeah.
That's right. So that right now seems like the logical future of pozzolanic cement or the replacement for Portland cement. Now, all of this is very important, and why Portland cement industry would welcome it rather than being threatened by it, like you pointed out, is because Portland cement industry will have to cut down on their emissions in order to meet the IPCC goals. And the only way they can do it, there are 2-3 ways they can do it. One is the fuel consumption, replacing that with renewable energy, and the other is replacing the clinker with this kind of substitute materials. So they would be under compulsion to adopt these technologies.
Okay, great.